1. And welcome. Welcome to this lesson, section 2 in chapter 8, separation of variables. These questions on the AP test, when they show up, notice I said when, not if. When they show up, you will have to use the separation of variables technique. And you'll see when I'll give you some of the solution guides for some of these problems. And basically, out of a 9-point question, if you don't separate the variables, you would lose like 5 points. And it's just one step that you can lose all the rest of the points for the problem. And I'll show you what I'm talking about in a moment. But separation of variables basically means we're going to put all the y's on one side, the x's on the other side, or it could be other variables, obviously. But in this case, we have x's and y's. So we have 2y. We got y prime equals square root of x over y. So first thing we're going to do is we're going to take this y prime and we're going to make it into dy dx. Okay? dy dx. And the reason for that is because dy and dx have two different variables, don't they? So we're going to say dy dx equals square root of x over 2y. Now, what the goal is to get all the y's on one side and the x's on the other side. And you want your dy and your dx, they are eventually going to be on different sides, but you don't want those in denominators. If you got a dy in the denominator, you got to get it to the other side. All right, so that's a quick note, a little tips and tricks. You don't want your dy or your dx to be in the denominator. And so in this case, see the dx is in the denominator? So this indicates to me that if I multiply by dx to both sides, then my dx over here will no longer be in the denominator. And it helps me to distinguish that I'm going to put the y's on this side with dy and put the x's on this side with dx. So my first step is going to be this. Let's multiply by dx because then it's no longer in the denominator. And I'll have something that looks like this. dy equals square root of x over 2y dx. So we got our x that kind of collected over here. There's no more x's over here. And my next step would just be simply using algebra. We're going to collect and put the y's over here. So I'll multiply both sides by 2y. So multiply by 2y many times. Get a little bit of weight on here.
Could you just cross multiply?
Yeah, I try to avoid the term cross multiply because people get confused and try to do all kinds of wacky cross multiply things. But if that works for you, definitely. So this is what we're doing. We've got a new equation that's going to be called 2y dy equals, I'm going to write this, hope you don't mind, as x to the 1/2 dx. Just easier to integrate what you want to do. Radical. Now notice here, bless you. Notice here, ladies and gentlemen, we got our y's on the left, our x's on the right. That's typically how I do it. Y's on the left, x's on the right, but obviously we matter which side. But our next step here, because we have y prime, we're trying to find the solution to this differential equation, we're going to integrate both sides. We're going to integrate this side with respect to y, and this side with respect to x. How nice is that? Because we separated them. So it looks like this. I'm going to put an integral sign here, integral sign here. Don't those both look like integrals we know how to do?
Yeah. Okay,
so on the left-hand side, we get y squared. And should I put plus c?
No.
Well, you could. We'll come back to that. Let's put y squared plus c for now. Call that c1. What's that?
That's one the C's canceling.
Well, let's just pause it. We'll pause on this. We'll come back to this side. What would this one be if I integrate?
2/3 x to the 3/2.
Yep, 2/3 x to the 3/2 plus c2. Now these c's are not the same, so I could not say c cancels c because the constants they might be the same, but we don't know. But what is true is that this c1 and this c2, we can subtract c1 from both sides, and I would get minus c1 minus c1. I would get something like this: y squared equals 2/3 x to the 3/2. Now watch, this is kind of magical. Plus c. Yeah, like why would I bother writing c2 minus c1 when I don't know what c2 or c1 is?
Oh, there's just constants.
They're two unknowns, right? So as long as whatever they subtract to, it's going to equal this, right? It's going to equal some other constant. So what the moral of the story is, when you integrate, you don't have to put a c on the left side. Just put it on one side or the other, because eventually the constants will come together. They'll create a new c that is also unknown. So if you have an unknown number, and you add another unknown number, it creates a third unknown number. And so this is our unknown, our one and only one that we need. We don't have to have a bunch of C1s and C2s and C3s if you're going to add them all together anyway. Alright, so is this over with? Well, perhaps, but simplifying to make a y equals is even better. Y equals plus or minus the square root of 2/3 x to the 3/2 plus c. Now, could I say the square root of c is just c is still an unknown? We could just call it just plus c? Why not? Algebraically, you can't separate these in the square root of both, right? Okay? Algebraically, this square root can't be applied to this and then separately to this. So you have to, this would be the answer here. You plus and minus the square root of 2/3 x to 3/2 plus c. What questions do you have on this? This is the solution. So what questions do you have? You're going to love this unit. Let me put it this way. You will love this section if it's your favorite section. Okay?
Oh, that makes a lot of sense. That makes sense.
Yeah, it makes sense? Okay. Maybe I like it also because it's so close to the end. It's not super long. We're gonna say very little on the second page. Okay. Example 2. Solve the differential equation. Now, this is a very typical one. This is, dare I say, a very popular one on the AP test. Okay? If there is going to be a popularity contest in the AP test, it'd be this problem. We could probably win every year. We have 2 y prime equals y. So we do something like this. 2 dy dx, because y prime equals dy dx equals y. By the way, do we all agree that y prime has dy dx?
Yes.
Okay. This is the derivative of y with respect to x, y prime. Okay, now what? What's going on here? We got a y on the right hand side, we got a dy on the left. We got an x on the left hand side, but we don't want that to be mixed up with it. And it's in the denominator. What do we do first? Should we do what? Multiply by half? You'd rather have the half over there? You can. To me, we got to get the variables separated. That's the first goal. Let's multiply by dx and see what happens. So we go times dx over here, times dx over here. So we get 2 dy equals y dx. Now, this is an issue because we can't integrate that. Can't integrate y with respect to x because there'll be 2 variables in the integral and you guys haven't learned it yet. So now we have to do what? Let's divide by y. And so we get this new equation. We get 2 over y dy equals dx. Now, if you're someone who doesn't like the 2 over there, then move it. I don't care. I mean, it's not going to matter to me at all. But it's up to you. It doesn't bother me. I can integrate this. You're either going to have to integrate over here or over here. So let's go ahead and integrate. What is the integral of 2 over y dy? Yeah. Yeah, here we go. Here we go. Now you guys are cooking with butter. And what's over here? X plus c. Okay? So if I integrate this, I get 2 times the natural log of y. Integrate over here, we get x plus c. We agree? You see how we got that? Jacob, you with us? Looks like I lost you for a moment. All right, we got to solve for y. Well, we probably should divide by the 2. Okay. By the way, you could have done that earlier, like I said, right? Divide by the 2. Or this 2. Couldn't the 2 go up here on the y?
What tells you that you need to solve for y?
Because we're trying to solve the differential equation, and it's typically a y equals something. Not always, but typically a y equals something. Okay. By the way, just a little recap. This 2 could go up on the y. We agree? And then we wouldn't need the absolute value because y squared would always be positive or 0. But it can't be 0 because it can't naturalize 0. So I'm going to go with that. We'll put the 2 up top. You want it? By the way, I do want to just take this moment to let that set in. There's going to be more than one way to do this. Okay, so dividing by 2 would be acceptable. And I could do that a different way. I'll do it over to the board over there. But let's go ahead and just move this 2 up. And we'll call this natural log of y squared equals x plus c. Okay, how do we isolate the y squared? Yeah, exactly. Exponentiate. Exponentiate. So you e to this power, e to this power. Now here's something that's kind of exciting. Y squared equals e to the x plus c. Now I want to share something with you that is of utmost importance. We don't write this like this in math. This is not complete. The right-hand side, e to the x plus c, is not e to the x plus c. That's not how we're going to write it. We're not going to write it in here. You're not going to write this on the AP test. Here's what you do. You ready? This is what you're thinking when you see this. Bloop, bloop, bloop. We're thinking e to the x plus c, that's e to the x times e to the c. Sure is. E to the x plus c is e to the x times e to the c. Does anyone know what e to the c is?
It's another C.
It's another c.
Oh.
We don't know what it is, but e to the c is another constant. So we're not going to write it like this. We're going to write it like this. C e to the x. Because e to the c becomes c, becomes an unknown. So this is just e to the x times c, or c e to the x, which is what I put over there. Okay? So e to the x plus c is c e to the x. This is how we're going to write it. And when we solve for c, it's going to be here. And we'll solve when we get to question 4. Alright, so one last step on this. You can square root. You can say, y equals square root of c e to the x. In this case, c is being multiplied to e to the x, so square root of c would be c again. Still unknown. I have a constant, I take the square root, I still have a constant. I still have an unknown constant. And I know this goes against everything you learned in all of your previous math courses ever. But square root of c, we can just write c. What would e to the x be when you square root it?
E to the x to the half.
Yeah, 1/2 x or x over 2. This should be plus or minus, but this is only going to be positive. You're not going to be able to get a negative from this.
What if we just wrote it like the second one? Y equals root c to the x.
It would just look like you didn't simplify it all the way, but it's probably okay. The main goal of these, basically, anytime you have a c in there, you have an unknown. You don't know the actual solution. If there's a c, you don't know the actual solution. It's just you've got it narrowed down. When you get down to example 4, where they give you initial condition, you're going to have to solve for c. Okay? All right, let's try example 3. Should plus minus. All right, solve differential equations. This time we get to do some more advanced algebra. Not super difficult, but a little bit more advanced. Okay, we got x, y, plus dy dx equals 100x. I'm going to pause there and just let you take 2 minutes. So we separate the variables. We're going to get all x's on one side, y's on the other. So one thing I'm going to do right off the bat is I'm going to do a minus xy. Okay, now you might be thinking, Mr. O, how's this work? Because now you just have a y over here. So we've got dy dx equals 100x minus xy. So you're thinking, well, this doesn't help us because we still have the y. Yeah, we're going to factor out the x. Okay, and that's how we're going to separate it. We get all the x's on one side and we factor out the x. So it's going to be this, dy dx equals x times 100 minus y. So So I hope you don't mind if I do two things at once. I'm going to divide by the 100 minus y on both sides. Divide by 100 minus y. But I'm also going to multiply by the dx. Doing two things at once. So it looks like this. 1 over 100 minus y dy equals x dx. How nice is that? So I've got them separated. I've got x's on the left. I'm sorry, I got y's on the left, x's on the right. So they're separated. And when they get to the point where they're separated, I can integrate. I can just integrate. Now I want you to be so super careful on this one, because what a lot of people will do is say, well, the integral of 1 over 100 minus y is just a natural log of 100 minus y. Okay, why is that wrong?
You should separate it out, so 1 over 100 minus 1 over 1.
Well, you cannot do that. That's not allowed. Say it a little louder. Put it to the negative 1, but then what are you going to do? So you put it to the negative 1. 100 minus y. How do you integrate that? Does anyone think that this might work? How do you integrate this? The integral of x to the negative 1. What's this one? Galen, say it a little louder.
It's the natural log of x.
Natural log of x. If it's to the negative 1, it's definitely natural log. So why is this not natural log 100 minus y? Why is this not true?
Differentiate y by negative.
Okay, one at a time. Keely.
There's multiple things in the
That doesn't matter. If it's just x to the 1, you can do natural log of this. But what are we doing here, Ella?
The derivative of negative y is negative 1.
Yeah. So in this case, you would have to use substitution. Use substitution. If I was trying to integrate 1 over 100 minus y dy, you could say u equals 100 minus y, du equals negative dy, and so you make a negative. You say negative integral 1 over u du. So when you integrate, it would be the negative natural log absolute value of u plus c, and then you plug back into u, and it would be exactly what you started with. So you can do this, you just have to remember it's negative. The fact that that's 100 minus y means it's a negative. And if I took the derivative of this, ladies and gentlemen, you would get exactly 1 over 100 minus y. And what about the left-hand side? 1/2 x squared plus c. So I suppose the first thing I would do is I would call this multiply by negative. I would get natural log of 100 minus y equals a negative 1/2 x squared. And can I just call that plus c, you guys mind? If I'm dividing this c by negative 1, what do I get? C again. Still c. You can do whatever you want to c, so long as it's isolated incident, right? If you do 100 c divided by negative 1, and that's all you're dividing, then go ahead and just call it c again. The problem will become later on when we're trying to plug in and find out what c is. You need to plug it in at the right spot and know where you plugged it in. I'll explain that more later. So anyway, where do I go from here? Can we exponentiate? And I'm going to erase over here because you guys already saw that. So what color am I working on? Okay, so we get 100 minus y equals, what's over here? How about CE to the negative 1/2 x squared? Well, you know it's a good problem when you run out of space. Okay, solving this, I'm going to subtract 100 and I'm going to divide everything by negative 1. So it'd be y equals CE to the negative 1/2 x squared plus 100.
What do you mean negative?
You want to call this negative c? Go ahead.
It's still C.
Doesn't matter. Still c. Right? Doesn't matter. It's still c. If it's positive c or negative c, it only matters when you start solving for c. Then you can't treat it all willy-nilly like. You gotta treat it like it's an actual number. But because this is a constant, we don't care if it's positive or negative. Because it's a constant. It will be positive or negative. We just don't know which one. And we won't know until they give us an initial condition. If they give us a value for x and a value for y, then we can find c. And we'll know if it's positive or negative.
Would you have to keep the negative if they gave you a value for x?
If you plugged it in, let's just say this. If you plugged in your x and y here, then it would absolutely have to be positive or negative based on that. Okay? Wherever you plug in your x and y, then you gotta start treating c like a real number. I mean, it is a real number. But. What questions do you have? Example 4, we finally can solve. We can plug in some values and figure out what c is. How does that sound? Sound good? Wilson will
Are
do.
we gonna have problems like this where they give us like y each one?
Say a little bit louder.
Like you know the substitution problems where we have like y 0 equals this, y prime 0 equals this.
Yeah, that's mostly an 8-1 thing. Yeah, but you'll have to figure out usually just one time. You'll have to figure out this one. Okay, let's try number 4. Solve the initial value problem. We got y prime. In fact, I'm not gonna use purple. We'll start off with blue. We got dy dx. Okay, first step is to take your derivative and write it as dy dx. Minus x e to the y equals 2 e to the y. So I'm going to pause for a moment. I'm going to give you about a minute and a half, 2 minutes to try to separate these variables. Separate the variables. All right, welcome back. So hopefully you had a chance at home to pause the video and try this. Ladies and gentlemen, what I'm going to do is I'm going to try to collect all my variables on one side. So I know my x is going to end up being over here. But the other thing is, we can factor. This is how I do it. Got multiple ways. Let's add x e to the y on both sides. And when you do so, it looks like this. dy dx equals 2 e to the y plus x e to the y. Now the thing that I can factor out on both of these is e to the y. So I can rewrite it as dy dx equals 2 plus x times e to the y. I factor it on the right hand side. Trying to switch things up a little bit, keep it interesting. Now if I divide by e to the y and multiply by dx, I get this. I get 1 over e to the y dy equals 2 plus x dx. So this dx applies to the whole 2 and the plus. Now, a couple things to point out, and I mentioned this earlier, but I do want to remind you. Notice dy and dx would be considered in the numerator if they were in a fraction. Notice dy down here, or dx down here is no good, so we had to multiply it, so now it's in the upper level. Right? Keep that in mind as you separate your variables. You don't ever want your dy to be down in the denominator down here, or the dx to be in the denominator down here. Right? So just keep that in mind. And now I can integrate, but what's going to be easier to integrate is to rewrite this. I'm going to write it as e to the negative y. Isn't 1 over e to the y just e to the negative y? Can you agree with that? You can't agree with that? Or can you? Okay, so if I just integrate, what's going to be the integral of e to the negative y?
Negative e to the y, negative y.
Negative e to the negative y. Right? If you use u substitution, u would be negative y, derivative would be negative 1, and so on. So our integral is going to be, after I integrate, it's going to be called negative e to the negative y equals, this is going to be 2x plus 1/2 x squared plus c. Now at any point in time after I integrate, I can plug in my initial condition. I can plug it in now, or I could solve all the way until find out what y is and then plug in. But we need to figure out what c is. You could plug it in now if you wanted. But remember that when you, if I do choose to plug it in now, then manipulating C the rest of the way, I will have to consider the negatives and adding and dividing and all that stuff. Okay? But typically, I look at the problem and I think, what would be easier? Because if I plug in a 0 for y, this is y, this is x. If I plug in a 0 for y, this becomes easier, right? Than if this were a different number.
Does it come with negative one?
Negative 0, then it would be negative 1. Yeah, absolutely. So let's go ahead and plug in now. And we'll use P for plug in. So I'm going to plug in these values. X is going to be 0, and y is going to be 0. So we say, this plug in is 0 here, we get negative 1 equals 0 plus 0 plus C. So that's why it would be a good place to plug in. Notice if I didn't plug in, I would have to take the natural log of both sides, and that could make things complicated. Things could get complicated. All right, so at this point, if I plug in a negative 1 for C, we still want to solve, and for solve, we got to use orange. We still want to solve for y. So we get negative e to the negative y equals 2x plus 1/2 x squared minus 1. How nice is that? And so if I choose to get rid of divide by negative 1 or multiply by negative 1, I get e to the negative y equals negative 2x minus 1/2 x squared plus 1. Right? I have to, now C is important. We know exactly what it is. So any algebraic operation you do, it does need to actually apply to C. And so my last step would be to take the natural log. To get, we got y in the exponent spot, we gotta take the natural log on both sides. So natural log will be done in orange. No, I want blue. Take the natural log over here. Take the natural log over here. Do I use absolute value here for natural log?
Yes.
Do I use natural log absolute value? No, that's only when you're integrating. Don't make up new rules for algebra. Okay? For integration, if you got 1 over x dx, it's natural log absolute value of x. When you're just using algebra, everyday algebra stuff, you can't just make everything absolute value just because you feel like it. So this is what we're going to do. We're going to call it negative y equals natural log negative 2x minus 1/2 x squared plus 1. And then the last step would just be divide by negative 1. So we get y equals a negative natural log of all this stuff. Negative 2x minus 1/2 x squared plus 1. Done. This is our solution. This is a particular solution to this differential equation that goes through this point, 0, 0. Okay? It's good to recap, right? It's good to think back. What are we actually doing here, Mr. O? We are finding a solution. We're finding one equation that makes this true. We're finding an equation that makes it true, given this information, 0, 0. It's got to go through 0, 0. In 8th grade, we're gonna look at slope fields, and we're gonna see there's infinitely many solutions to the differential equation. But when they give you a value, then you know exactly what this solution is going to be. What questions do you have? Okay. Crickets. Okay, ladies and gentlemen, for the sake of time, I'm just going to kind of talk through this one. Okay, we're going to talk through it a little bit because in Algebra 2 and in pre-calculus, you guys spent time. Let me pause it. In Algebra 2 and in pre-calculus, you guys spent some time doing half-life stuff and exponential growth. Okay? We can use calculus. You can use calculus to do this. But in my opinion, it's not any easier to use calculus. So when you're asked a question about half-life, you can use the same skills you've always used before. Okay? But I do want to explain how it's going to connect, and then I'll also do problem. Ready? All right. So consider the following problem. According to the United Nations, the world population in '98 was 5.9 million and growing at a rate of 1.33% each year. Assuming exponential growth model, estimate the world population in 2022. All right. Now, you guys remember this, hopefully.
This is our worst.
Yeah. If you want to try to find some new value, I think they use y equals or a equals, and it was PE to the RT. There's a principle, this is your rate of change, and this is how much time went by. You guys probably remember this hopefully a little bit, compound growth.
That's crazy.
Right? And so if they give you the growth rate, you plug it in here, you put in how much time, you put in the initial amount, you get your final. That's it. Right? You remember doing this a little bit? 5.9 billion would go here. Your T would be from 98 to 23, so that's 25 years. Maybe 25. And R would be your growth rate. A growth rate of 1.33 is actually 0.0133, right? You plug it all in, you get your answer. Done. Now, why would we do calculus? Well, here's how you can do it. You got your initial. You want to find out what is the population at 25 years from now. Okay, so using calculus, let's take this and put a box around it. I don't want to do that, do I?
That's so stressful.
We don't want this. Watch this.
I'm actually so sorry about that.
Just no. We don't need it. We don't need it.
This is something that's going to be so good. Still didn't work. Okay, anyway.
Bro, that's so painful for the eyes.
Well, you want it to be a different color or something?
Yeah.
Let's do this. Is that better? Okay. So, this is not what I want to do either. So this here, this is how we would do it using Algebra 2. So let's look over here at the calculus side for a moment. Okay? This is quite simply put. We figure out what is the new, this is your principal amount, your starting position, 5.9. That's why it goes in for C. Okay, but let's look over here. We say the derivative is going to be 0.0133 times the population. Okay, this is our growth rate, and we're multiplying by the population. That's why it's a differential equation. The rate of change is equal to the rate times the current population. That's why it's a differential equation. We have a derivative and original function in the same equation. Okay, so on the front side, this would look something like this. Y prime equals 0.0133 times y. This is what it would look like if we did it on the front side, on the front page. Okay, it's the exact same thing. We have a derivative that equals something times the original function. That's why it's a differential equation. So then you just simply, we're going to do separation of variables. We're going to divide the p, and we're going to multiply by the dt. We're going to integrate, and we're going to end up with this equation, PERT, which is what we have here. Okay? You already, as far as I'm concerned, you already know this. You recognize this. This is what you should use. But this is the calculus behind it. This is how we get to this position. Is that clear?
Do we need to know the calculus behind
This is not super important to me that you know how to do this. We're going to have plenty of practice on separating variables and integrating. But for these problems with growth rates, continuously compounded growth models, I would say half-life, population growth, population decay, stuff like that. I would just jump in right there.
I'm just confused because that's not the same thing.
Show me which one you're talking about. This one?
Yeah.
This is exactly the same. We just call it P. This P is in, I call it principal up here. Principal. This is your starting initial amount is your principal.
Okay.
Yeah, it's using different letters. It looks different. And here I call it P per population. So I know the letters don't match, but.
Okay.
PERT. And that's the same with your ideal gas law. PV equals nRT. Pivnert. I used to call it Pivnert back in college. Me and my buddy. Okay,
Oh yeah.
so initial value problem. By the way, this is a recap of what I just talked about. You can read it in your when you got free time. You always do. All right, example 6. A cell of E. coli divides into 2 cells every 20 minutes. It's the best. When placed in a nutrient culture, let y equal y of t be the number of cells that are present t minutes after the cell is placed in the culture. Assuming the growth of bacteria is approximated by the exponential growth model. Exponential growth model, PV equals nRT? No. Perfect. This is your exponential growth model. When they say exponential growth model, this is exactly what they're talking about. Exponential growth model. Okay? So, find the initial value problem whose solution is y of t. When they ask you this question in your bookwork, what they're asking you is the population is going to be twice as much, the growth rate. So you're looking for something like this. You're looking for a derivative that's based on your rate times your initial times your population. And in this case, when it doubles every hour, how's it going to look? The derivative is going to equal what? The rate of change is what? That's the question.
Yeah. I'm convinced.
So we have your population. This is your original population, your rate, and your final population. Now, if we put 20 minutes in there, if we put 20 minutes in for t, we should get twice as much as the original population. If we put 20 minutes in for t, we should have twice the original population. Correct? And so when I divide it out, we get this. You guys want me to start from the beginning? Do you agree with me that if I put 20 minutes in, I'll have twice the population? Okay, so every 20 minutes is going to double. So then, by dividing y naught, we get 2 equals e to the k times 20, or 20k. And so, you solve for k. You got to find out what is this growth rate. What does k equal? So we take the natural log of 2, and we get 20k. So our k value is going to be natural log of 2 over 20. And that's going to give us a number, which I just erased. You don't remember what it said? I wrote it down. Do we have it on there? It's small. Natural log of 2 divided by 20? Hey Siri, what is the natural log of 2 divided by 20?
The answer is approximately 0.034657.
Never had seen it that often. So let me make a web search. Alright, here I could just do this.
Okay, this is k. We put 0.035 up there. I guess I could have just gone by that, couldn't I? You plug it in, and then they say you can answer all these questions. Find the formula. Here's your formula here. Find the formula for y of t. K was point, straight down here. K is here. Okay, so my question is this. Then it says, how long before there's a million cells? You put a million equal to this. Because it started with 1, didn't it? Started with 1. That's your initial amount. So it's going to take approximately 394 minutes. Ladies and gentlemen, by the way, that's quick. From 1 cell to a million cells in under 4 hours. No, more than 4 hours. Sorry. 13, 14 hours.
Mr. Ray,
That's quick.
is this very prevalent on the AP exam?
Huh?
Is this prevalent?
This is what it looks like on the AP exam. Good question. Good question.
Are we gonna see a lot of
Oh,
them?
where'd it go?
Mr. O, if you weren't a teacher, what would you do?
Race car driver.
He answers
No.
I don't know why these haven't been showing up lately. I just looked at it a few minutes ago. I'll pause this. Okay, ladies and gentlemen, we're back. All right, your third page. Now I need your attention for probably about 10 more minutes, believe it or not. Here's how the problems look on the AP test. And there's a problem from 2 years ago or last year, potato problem. And everyone after the AP test, they come talking to me about the potato problem. And that was exactly 8.2 problem. Okay, consider differential equation this. Let y equals f of x be a particular solution to the differential equation that passes through this point. Okay, stay with me now. Particular solution means you need to get no c. Means you need to figure out what c is. Not a general solution that has a c in it, but a particular solution. So we need to use separation of variables. We need to figure out what the equation is, and we also need to figure out what C is. Okay? Where do we do that? B. Find the particular solution. Kate, can you stop? Part B. Find the particular solution differential equation that passes through. This is the part we're doing right now in chapter 8, part 2. Part 1, write an equation for the tangent line. How will we do that? This is a review. What do you need? You need two pieces of information for an equation for tangent line. You need point and a slope. Okay, how will I get, I don't know, a point? I'll give you the point. How will I get the slope? It's the derivative. Derivative's here. So if I plug in a 1 and a 0, plug in a 1 here and 1 here and a 0 there, I should be able to get the derivative. So I would do something like this. dy dx at the point 1, 0 equals e to the 0 times 3 times 1 squared minus 6 times 1. And that would be 3 minus 6. Negative 3. So if I know my point and I know my slope, I'll do y minus 0 equals negative 3 times x minus 1. This would be the equation, and then you want to use that equation to approximate 1.2. So you put a 1.2 in there, and you figure out your equation. Alright, so that's old stuff, that's review. That's why I'm rushing through it. New stuff. Gotta separate the variables, have to integrate. So we're gonna do this, we're gonna say dy dx equals e to the y times 3x squared minus 6x. Now we gotta divide by e to the x, so it's e to the negative y, I call it e to the x, but e to the y. E to the negative y dy equals 3x squared minus 6x dx. Bless you. Now, if we go ahead and, so should I go ahead and plug in my 1, 0 now? Should I plug in 1, 0, my point at the beginning? To integrate first. Yeah, you can't just plug it in wherever you feel like it. Integrate first, and then you can plug it in wherever you feel like. How's that sound? That's a deal I'll make here. So we integrate both sides. When we integrate, we get negative e to the negative y equals x to the third minus 3x squared plus c. Looks a lot like the problem we did on the very first page. We need to figure out what c is because it says find the particular solution. It means find out what c is and write an equation based on it. Yeah, I would plug in right here. This is exactly what I would plug in.
It's the same problem.
Is it the exact same? Because I think we did 0, 0 last time. But if I plug in at this point, let's go ahead and plug in. I'm going to plug in a 1 and the 0, so I'll get negative 1, because I'll get negative e to the 0, which is negative 1, equals, and we plug in a 1 there, we plug in a 1 there, and we get 1 minus 3. It's negative 2 plus c. Add 2 to both sides, and we get 1 equals c. Create c. All right. Now we go ahead and we plug in, I would plug in the c there, then solve for y, and you're good to go. So at this last point, we're going to go negative e to negative y equals x to the third minus 3x squared plus 1. And the rest of the problem is algebra solving for y. And to be honest, find a particular solution, I think they would accept this. I'll have to look into that more. Well, I don't know. No, let's see. It says y equals f of x. I think they might want you. Let's keep going. I'll look into it, but that might be an acceptable solution. If not, you need to do this. E to the negative y equals negative x to the third plus 3x squared minus 1. If we take the natural log of both sides, we get negative y equals natural log of negative x to the third plus 3x squared minus 1. And then we divide by the negative. Y equals negative natural log negative x to the third plus 3x squared minus 1. This would be your particular solution. And I think because it says y equals, they wanted it over here as y equals. Y equals okay. Okay, so I'm gonna pause there. We'll get into notes. Spend some time for spend 2 minutes, try to get letter C on the next part. Try to get C yourself, and I'll come around and check them.
No.
Yes, try it.
Can't be reversed.